Okay, let's continue our project of trying to describe the solution sets of systems with an infinite number of solutions. Okay, here's this example we tried last time, or we solved last time, and the original system is on the left and the echelon form system is on the lower right. I should have a 0 equals 0 equation down here, and I do, okay? So let's try solving the second row equation for y in terms of z. That we end up with adding y to both sides here to get y, subtracting 6 from both sides to get y equals minus 6 plus 4z. And then we can use this expression in the first equation to solve for x. Okay, so here's the first equation with expression for y substituted in. And we have an equation for x in terms of z, which we can do the algebra and write it like this. So the point is that we've been able to write both x and y in terms of z. Okay, so let's examine what this buys us. And here's our system. Here's these two equations where we've parameterized or solved for x and y in terms of z. You can see that it's easy to find triples. That's what you've got. You take any value for z without constraint, and you plug it in, and you get a triple for y. Okay, and it's also to see which ones are not triples. For example, if I choose y equals 3 and x equals 1, I see that 3 minus 3 is 0 and x equals 1. You can see that if I choose z is 0, I can only choose x equals 0 here. I can't choose anything else. Okay, so here's how we write the solution set. It's all the triples where the order in the triple is always the same. The order of variables in the triple is always the same as the order in a linear system. So we have the x term here, 3 minus z, the y variable here, minus 6 plus 4z, and z, which is just z. So this form is much superior to the previous forms because there's no constraint. I just put in z and read off one of the answers. Okay, since this is going to be an example of the general form, we're going to introduce some terminology, some concepts that will allow us to identify that general form. In echelon form version of the system, the first variable appearing in each row on the left is a leading variable. All the other variables are the system's free variables. We'll see in a second some examples. A parameter is a placeholding variable which acts as a bridge between expressions. We will parameterize the solutions of linear systems with its free variables. Let's see how this works with some examples, okay? This system is already in echelon form, and we can examine it and see that in the first row, x is a leading variable. In the second row, y is a leading variable. And those are the only leading variables so that z and w are free. And we're going to parameterize the solution set with z and w. We'll solve the second row for y, the leading variable in terms of the free variables. That gives us minus 6 plus z plus 4w. Substituting this expression into the first row gives 2x plus the expression for y plus z minus w equals 5. And doing the algebra to solve for x in terms of z and w produces this line here, that x is 11 halves, a constant, minus z minus 3 halves w. Now, these two equations allow us to write down the solutions, which are going to be 4 tuples, 4 numbers. And I can choose z and w. There's no constraint. I can choose z and w to be anything. And so the x term is 11 halves minus z minus 3 halves w. The y term is written here, and z and w. So this is similar to the previous form. Now you might think that the free variables are always like the last two. And so the following example is a counterexample to that. But here's another echelon form system. The leading variables are now x and z, and the free variables are y and w. And we'll parameterize with those two variables. So we're doing back substitution. still. And so if I solve for z in terms of w, put that in here, and solve for x in terms of y and w, I get the following equations. And I've added two equations for the free variables, y equals y and w equals w. So I have over here x, y, z, and w, which are the four slots here, x, y, z, and w. So I can just read off the right-hand side and put them in the right place. This first expression here goes here, the y goes there, 1/4 plus 1/2 w goes here, and the w goes here. Again, y and w are unconstrained, so this is a useful formula solution. It's still a little bit congested because it's hard to sort of see what's going on with all these terms, and we'll see a way to deal with that shortly. But that's it for now.